First off, I want to apologize for my very low-tech approach to this. Hopefully it gets the job done. The video I wanted to make is explaining some geologic principles. And the reason I want to do this is because geology is the study of Earth. Thus, it is one of the sciences that is, chemistry and physics and math, those are all around us all the time. But geology is one of the few that you can really go out and touch and feel, and you can go out and see. If you're out on a drive, you might see a beautiful scenic, and I know that my photos are a little blurry, but this, you can still sort of get the idea that this is you would look out over a beautiful landscape, and with some knowledge of the geological principles, you can do this really cool thing, maybe impress all your friends, where you can actually tell the story of what happened. How did it come to be? What was it before? Where did it come from? It's very exciting. It's in a way it's like learning to read the rocks. So we're just going to go over a couple geologic principles that would help you to be able to read rocks. The first one is the principle of superposition. Super meaning like above, and position, meaning like placement or whatever. So superposition basically says that the youngest rocks are on the top. Okay, here's an example. Here I have an outcrop of rocks, and you can't see it really great, but there's some layers. You can probably tell at least that there's a few layers. This is sort of ground, so I'm kind of going to ignore everything down there. Up to here, I sort of have a distinct layer. There's a thinner layer here, which is very, it's got a lot of, it's like a lot of rocks. This is more of a fine grained, and this is much more coarse grained, is what I'm trying to say. So this has a very distinctly different texture than the layer below it. And then the layer above, I'm actually not entirely, I'm going to maybe put, this is a layer and then this is a different layer. Although, to be honest, looking at the photo, it looks like there was a little bit of moisture, which is why I think this area is discolored. And I'm not entirely sure if this is a very different rock than this, or if this is just sort of like wet or weathered or colored a little differently. This, by the way, is why your geologist will often carry a hammer, because he would maybe take a sample of this rock, essentially smack at it to get a fresh face, so that he can see, well, on the outside it had weathered this gray color, but on the inside it looks the same as a fresh face of this rock does. Anyways, the law of superposition, I said, is that the older rocks are on top. So this is oldest, youngest, and this one is middle. The idea is that, strictly speaking, about sedimentary rocks, which I am not going to get into the different rock types. I'm going to assume that you have some knowledge of what's metamorphic, what's igneous, what's sedimentary. That's a whole other topic. Sedimentary rocks are deposited such that you have to have the oldest laid down, and then at a future time, new rocks are laid on top. So this oldest layer has to already exist, of course, for the newer layer to go on top. And then, of course, this layer has to already exist for the very youngest layer to go on top, and so forth and so on. So you can read the rocks in this way. You can say, these ones down at the bottom are the oldest. I know because it's sandstone that it was this type of environment. Then this middle layer is a different type of rock. I can tell from the type of rock that it was laid in this type of an environment. So I can tell you that in this one spot where we're standing, the environment went from this environment, and then it changed to that environment, and then it changed to that environment, and you can tell the history of that spot of land that you're standing on, which is, I think, it's sort of like magic. It's sort of like fortune telling. If people don't know how you're able to do this, it can seem sort of incredible that you can tell them this used to be a beach, this used to be a river right here. Okay, this is a very simplistic view of it where we went very clearly from oldest to middle to youngest, but I wanted to show one more example of where this really comes in useful. You can't see it real great again, but the rocks, you can see that the layering is going vertically, which is very different than it was here. Here the layering was horizontal, and that's the law of superposition. They're laid flat, and the youngest is on top, but here, well, I mean, they are not laid flat. So which is the youngest? This tells me that there was some shifting here. So it's possible that the oldest rocks were here and then up to the youngest, as superposition says, and then there was some tectonic activity that pushed these rocks up to almost vertical. What's interesting in this case is because they are almost vertical, it's possible that it didn't, the oldest is not down here and it was pushed up, but what if the oldest was down here and then that was pushed up? And it's even the case, you could have some rocks where the oldest was down here, it was pushed up, and then maybe it even flipped all the way around. So at first glance, you'd say, oh, oldest is on the bottom, youngest is on top. But as you look around, you might say, wow, I can tell that there was some serious tectonic activity. There's folding in these rocks around the area. I don't think that it was so straightforward over there. And you might be able to tell that, these rocks have been flipped upside down from their original position. So again, you would probably really impress your friends if you're able to say the tectonic activity was such that these rocks were flipped all the way around. So that is the law of superposition. That's what it looks like, oldest rocks on the bottom. The other principle to talk about is cross-cutting relationships. So if this was true in sedimentary rocks, what you often find in igneous rocks is that the rocks don't always so nicely lay down in little orders. It's not uncommon for there to be magmatic intrusions into rocks. So you had your original rock. Most of this is the original rock, like this. The original rock is often referred to as the country rock. It is the layer that was there first, often an igneous layer that was there first. Then, because there was molten rock magma in the area, it found its way, it intruded into that rock. Little sills of them intruded into that rock. I have here a rock hammer for scale. So you can see that these intrusions are, kind of big. If this is the hammerhead, it's as wide as a hammerhead. The cross-cutting relationship is that the thing that's doing the cutting is younger. So in both of these cases, the one that is super, the one that is above, is younger. In cross-cutting, the one that is doing the cutting is younger. So I would say that this rock is the original oldest rock. At a later date, this dark intrusion came in. And then what's interesting about this particular case is that there's another set of intrusions. You see these light lines. These, I can tell that they happened after the dark ones, not at the same time. They had to have been after because they are cutting through the dark ones. The dark had to be there in order for the light to cut across it, right? It doesn't make sense. If this light band was here first, it doesn't make sense that the dark one, came up to here and then, I don't know, like, this is three-dimensional, so maybe it like went behind that one and it just didn't happen to, no. It tells us that this light one had to have come after so that it was able to cut through. So these might seem, I hope these didn't seem really confusing. I think a lot of times they almost seem a little like difficult just because it's like, well, duh. The one had to be there in order for the other to interact with it. But just by knowing these really pretty basic principles, you could go out on a drive, see some rock, and tell part of the story of how those rocks came to be. And I've just hit my mark, so I will, I guess, go on to the next one.